This is Geometry, Unit 2, Transformations. We're working on worksheet 3. Here, we're looking at where the opposite of y and then comma x. So that we're switching the variables and we're putting a negative on the left-hand side. That looks like a rotation. Rotation 90 degrees counterclockwise. It's always counterclockwise unless otherwise stated. So one way we can do it is to turn and see exactly where they're going to be. 3 to the left, 3 up. 3 to the left, 3 up. That's going to be my A prime. 3 to the left, 7 down. So these two should be the same length. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that the length is the same. The other way you could do it was to simply know what your coordinates were. 3, 3. Negative 7, 3. Do the rule x comma y is going to become negative y comma x. So this A prime is going to become negative 3, 3. And B prime is going to come negative 3, negative 7. You switch the two numbers and you make the first number the opposite sign than it would have been. So either way works. So here we have a negative x and a negative y. You need to know what the rule is for this. So notice that the x and y are not switched. If they were both switched in opposite, then that could have been y equals negative x, a reflection over that line. But this is 180 degrees rotation. This is 90. This is 180. So we could come here and figure out our coordinates, write them down. So A prime is going to be 3, negative 1. B prime is going to be 2, negative 9. And C prime is going to be negative 1, negative 3. That's one way we could do it. And then turn it back around and plot them out. 3, negative 1, 2, negative 9, negative 1, negative 3. And we'd have the exact locations. Another way we can do it is to come on over and say that our A is at negative 3, 1. Our B currently is at negative 2, 9. And our C value is currently at 1, 3. And if we were going to do our rule of x comma y, is going to become negative x, negative y, then our A prime is going to be the opposites of what we have. 3, negative 1. B prime is going to be 2, negative 9. And C prime is going to be negative 1, negative 3. we can compare that with what we calculated earlier and see that they matched. So either process works. It's up to you to determine which is best for you. It's 3, negative 1. That's A prime. 2, negative 9. That's B prime. And negative 1, negative 3 is C prime. And then sometimes we like to shade in our image. Just an easy identification when you're looking at a picture for the first time. You need to have the prime marks on there. Okay, for this one, we need to change up some of the letters. Some of the letters are actually written in the wrong location. So if your form still has it in the wrong method, you need to make this one be Q prime and U prime and A prime and D prime. We need to write the rule for what's happening. So some of our first thought is it a 90-degree rotation? So if I rotate it 90 degrees, it's going to land down here. So no, definitely not that. Is it a reflection? Definitely not a reflection over the x-axis. Not a reflection over the y-axis, because that would put A up here in the corner. So not that. Not a reflection over y equals x, because that would put Q down here in the corner. So not that. Let's see, that's 90, that's 180 degrees, so not that. 270 degrees, well that's interesting. That means that Q is 1 over and 4 up. D is 3 over and 1 down. Q is 1 over and 4 up. 3 over and 1 down. That seems to be it. It's 270 degree rotation. So that rule is to switch the x and the y, and your opposite sign is on the right. You can test it out. Take your, let's start with Q. Take the Q, and the Q coordinate is negative 4, 1. Follow the rule for Q prime, and we're going to switch them 1 comma negative 4, so now it's 1 comma positive 4, and that's exactly where we're at. So let's try it again. U is currently at negative 6. 6. And U prime would have to be switch those, and the second one change the sign. U prime. Perfect. And you could continue and you could test the rest of them. So we know that that is in fact the rule. You can test your rule to be sure that it works. Okay, we've worked with this type of shape before, but now we're going to rotate it 90 degrees. Well, an easy way to do that is to turn your paper and take a look at what the coordinates are. So we rotate the paper. So A prime is going to be 2, negative 7. B prime is going to be 2, negative 1. C prime, 6, negative 1. And D prime is negative 1, 7. Okay? So we could come back to the very beginning now, back to the original format, and we could plot those points. And it would be exactly where it belongs. Or we could figure out the A coordinate, which is -7, -2. The B coordinate, which is -1, -2. The C coordinate, which is -1, -6. And the D coordinate, which is 7, 1. And now we can apply the rule to it. So A prime, okay, so our rule for a 90-degree rotation is to switch the signs and put a negative on the left. So we're going to switch those and get 2, -7. Switch those and get 2, -1. Switch those and get 6, -1. And switch those and get -1, 7. And if you compare that, we see that they match up exactly. So let's plot them out. That would be our A prime. That would be our B prime. That's our C prime. That's our D prime. And there it is. Perfectly rotated 90 degrees. And you can test that by rotating it and seeing how it would lay in there. A, B, C, D. We graphed it. A, B, C, D. A prime, B prime, C prime, D prime. Rotate this guy 270 degrees. We can take the coordinates. -5. +8. So you have your signs right there. B, -2, 1. C, 0, 5. Our rule for rotating it 270 degrees is to switch the X and the Y and put the negative on the right. So our A prime is now going to be 8, 5. Our B prime is going to be 1, 2. And our C prime is going to be 5, 0. So where we're going to be is 1, 2, 3, 4, 5, 6, 7, 8. Whoops. 1, 2, 3, 4, 5. And that's A prime. 1, 2. That's my B prime. And 0, 1, 2, 3, 5, 0 1, 2, 3, 4, 5. That's my C prime. We can see from C to B, C prime to B prime, 2, 4. 2 to 4. Here we got 2 to 4. A, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. A to B, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So I'm looking at the lengths essentially, using a slope concept to be calculating the distances, and they're coming out to be the same. Here we're going to rotate 180 degrees. So that's where it should end up. We can test that. Our A, 5, negative 3. B, or sorry, not B. Let's call that D. Zero, negative 3. Q, seven, 7, and U is 9, 2. Well, we're going to use our rule for 180 degrees, and that is negative x, negative y. So in this case, we're going to just change the sign. So A prime is going to be negative 5, positive 3. D prime is going to be 0, 3. Q prime is going to be negative 7, 7. Negative 7, negative 7. That's Q prime. And U prime is going to be negative 9, negative 2. So we can plot those. That's our A prime. That's our D prime. That's our Q prime. Okay, it's overlapping a little bit. I should have paid attention to that some more. See how low it comes? And that's what we had for the Q prime. So now on the flip side, look at some true and false questions. After rotating a segment 90 degrees counterclockwise around the origin, the x and y coordinates will switch, and the first coordinate will change its sign. Well, x comma y, 90 degrees counterclockwise, we switch the x and the y, and you put a negative sign on the left. And the first coordinate will change its sign. So that's true. After rotating 180 degrees, the x and y coordinates just have opposite signs. Well, if we take this and we rotate it again, which gives us x comma negative y, and put the negative in the front because it's again a 90-degree rotation, both coordinates are back in the normal direction and they just switch their sign. Rotating 270 degrees, well, we're going to switch those so it's negative y, negative x, but change the negative to a positive so you get y comma negative x. The x and y coordinates will switch, that's what they've done, and the first coordinate will change its sign. Oh, it's not the first, it's the second coordinate will change its sign. So this one is false. This one here was true, and the top one was true. That was the tricky one. When rotating 180 degrees is the same as reflecting over the x-axis and over the y-axis. Well, x comma y, 180 is negative x and negative y. Over the x-axis is just changing the y, and over the y-axis would be just changing the x, and now we're right where they were the same. So this is true. Let's match these up. So here we have the second value is negative, so it's a reflection over the x-axis. Here they're both negative, so that's a 180-degree rotation. Here we have a translation, 3 to the right and 9 down. It goes to the right and then down. Here, just the left side has a negative, so that we know it's a reflection over the y-axis. They're just switched, so we know that it's y equals x. Here it's switched with the negative on the right-hand side, which makes it a 270-degree rotation. A translation to the right and up. Here we're switching them and making them both negative. We know that that's going to be y equals negative x. Switch them and place it on the left-hand side is going to be a 90-degree rotation. It is very helpful to understand your rules. You don't have to just memorize them. You can try to visualize what they mean. The reflections are very recognizable on what they do. The translations are very clear. The rotations, 90 and 270, you have to switch the x and the y. And then put a negative on just one side or the other. So here we're going to apply that given rule. So y comma x, that's going to be a reflection over the line y equals x. So that's a positive slope of 1. Y equals x. Now you could either figure out their coordinates and then switch them, or you can count 1 and a half, and 1. 1, 1. How many steps does it take to get to the line of reflection, and how many steps does it take, or the same amount of steps it takes to get past? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's our values. If we were to do it with the coordinates, we would start off with our first point, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And we're going to switch them to become 5, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Exactly where we said. 1, 2, 3, 4, negative 2. Negative 4, negative 2. Switch them to get negative 2, negative 4. Exactly where we said. And then this last one, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 6, 6 becomes 6, negative 6. Exactly where we said. So either method will get you there. This one, a negative on the x and a negative on the y, is a 180-degree rotation. So it might help for us to know what the coordinates are. Zero, negative 6. Negative 2, positive 6. Negative 8, 3. So our rule is going to be to change the sign. So you still get 0, but you get positive 6. Positive 2, negative 6. Positive 8, negative 3. And we can plot those points. So it's kind of like an L shape. Well, if we take our picture and we rotate it 90 and we rotate it 180, it's that L shape. You could look here and you could look where the coordinates are. And then you could turn it back and plot it. Either way. Last one. This translates 3 to the left and 4 down. 3 to the left, 4 down. There it is. You could take your coordinates, 6, negative 2, Those are your 3 coordinates. Now we are going to subtract 3 from the x. We're going to subtract 4 from the y value. Subtract 3 from our x, and subtract 4 from our y. Subtract 3 from our x, subtract 4 from the y. So this becomes 3 comma negative 6, negative 6, 4, negative 7, 1. Six, 4, 7, 1. Negative 7 because it's to the left. 1. 3, negative 6. Worked out perfectly. So you can do these by looking at the shape. You can do these by using the coordinates. Using the coordinates are very organized. That's what I would prefer. But if you can understand and see how they move, you can turn the paper and figure out where their locations are. Good luck.